Good evening, everybody, and welcome to the stream. I hope you're having a great Tuesday. Tonight, we're going to be looking at some refactoring. My name is Christian. I'm the author of the book 5 Lines of Code, and I've been looking so much forward to this stream. It's going to be super fun. We're going to be going through a famous refactoring kata online that I've done before, but it's more than a year ago, so I've forgotten pretty much how it looks. So you'll be seeing pretty much my impressions as they were the first time I saw the refactoring kata. I don't know how to update the title. I'm not sure if I have the permissions. So if anyone knows anything about that, please reach out. And I'll be trying to keep up with chat while I'm doing this. So if you have any questions, just post them over there and I'll try to keep up. So without further ado, I think let's just get started, shall we? So the Gilded Rose refactoring kata, I know of it from Emily Brahe here, and there is Terry Hughes who apparently did it first, but I think this has the most variations. So the only thing I've done so far is just to check out this repository and load the Java version up in IntelliJ. And I'm no expert in IntelliJ or in editors or anything like that, so feel free to correct me if I'm doing something in a cumbersome way or not. I'm just looking at the refactoring mostly. Okay, let's get into it. The Gilded Rose refactoring kata has it has some testing framework set up right from the start, which is nice. So you can get right into it if you want to do a lot of testing. It also has this file, which is really the crux of the whole program. Can I make everything a little bit smaller so we can see more? Something like this. It has this file, the Gilded Rose. Let me know if the text is too small. I'll try to enlarge it somehow. Yeah, and in the Gilded Rose thing, we have some items, and then we have this update quality. And that's really what the Gilded Rose program is doing. It's calculating the quality of items that are for sale in this kind of this store called the Gilded Rose, I think. That's the meta around it. And this code is not written in a particularly inviting way. It has some loops, it has loads of if statements, and they're nested really deeply. It also has this item class, which is very simple. It just has fields, and then it has a constructor for setting the fields, and then it has a toString method. In the original rules of the refactoring kata, this one, you're not supposed to modify this file at all, pretending that there is a colleague who's very precious about this code. So we're not supposed to touch that. I'm not sure if we're going to keep that requirement here, because I think it gets a little more fun if we can mess around with all of these things too. So we'll see how that goes. Other than that, yeah, I mean, we could start reading this code from the top and just start going down. I think that's going to be a lot to keep in our heads while doing it. So instead, I actually like to just start by breaking up sort of this long method. It's way too long. So the first thing I would usually do is I would try to figure out, okay, from the bottom of the method, how do we read it backwards, so to speak? The first thing I notice is that we have one big if chunk here at the end, which seems to suggest that this ties together. Another thing that's interesting here is there are actually blank lines some of the places here, which also suggests that the programmer who put it there originally meant that this is a separate part from this, and these are both separate parts from whatever that whole thing is up there. So what we could do is just start by taking this code and extracting it to a method. I expect there should be some way to do this with the editor directly. Extract method, Control-Alt-M, I'll try to remember that. Oh, and before we do it, let's just quickly scan over it. It seems to handle whenever something's sell-in date is below 0, or we could call it expired, I'm guessing. So this we could extract to something called handle expired. Let's see how that works. Good, so now we already have some name for this thing. It takes an int. What will this int? Oh, that's the index of the item that it's actually doing. Instead of doing the item, I think actually we're gonna want to extract this item out of here. So can we just select this thing and say extract local? I would expect something like that. Introduce variable, replace all of the 13 occurrences in here. So now we have an item here, and we can actually just take the item instead of the integer. So when we have a local like this, we can just sort of extract it out like this, which I think is a little bit nicer. So it handled expired this item. Now I'm realizing now that this actually starts with an if, so it handles the things if they're expired. So I think I'll just rename this. Oops, that did something different. What is renaming them? That would be Shift F6. That is hard for me to remember. Handle if expired, because then inside of it, this code here is actually what's handling things that are definitely expired. So we could extract that and express that in a method too. Handle expired. Like this. Okay, so this is a little bit different because we have an if else. It's harder to sort of break apart. So maybe we should leave that for a little bit and then continue up here looking at what this is. This here seems to be decreasing the expiry date. So whereas all of this code down here was very concerned with the sell-in, this is also concerned with the sell-in. So I'm thinking actually, I disagree with this line break. I think these go together because I think this has to do with the updating of the sell-in field. So we can extract that and say update sell-in. Something like this. That also happens to want to take the I, and I dislike that again. So if we take this and extract it to a variable. What about the failing test? Yeah, we can fix that if that's something that bothers people. Like this, we have the item extracted out. We can talk about testing actually. That probably would be an appropriate place to start when we're doing refactoring. Okay, now we have something that's in a stable state. So testing. We have this failing test here and oops here, and it's just a fix me thing, right? We could just put in foo and it would be fixed, I expect, because it's just looking at the thing. After it's updated the thing, it shouldn't change its name. So now we have fixed the test. But so this test is not really that useful. It doesn't really test anything interesting. What we could do is start going through what sort of paths we could go through in here to get some test coverage. And we would need, I'm guessing, around 11 tests or something to get through a lot of the ifs because they're so deeply nested. We need to really take care. Maybe we need actually 16 test cases or something to hit all of these cases. But in keeping with a style I like, where we try to do as close to, let's say, how industry code often ends up looking, there isn't a lot of test coverage from the beginning, and sometimes you can do some simple refactorings without messing things up, especially because so far I've pretty much only been having the IntelliJ do all of the refactoring, which sort of makes me confident that we're not breaking anything. Of course, the only way to know would be to test it and see if it still works. But yeah, or write. So we could write a lot of test cases for that. We could also just try to write one test case that would be really specific. I just find that testing for a stream takes a while and it's not necessarily the most interesting thing. Unless that's what people want to see, then of course we'll do it. So it's up to you is what I'm trying to say. We can definitely do testing if that's something people would like to see. I hope that answered your questions. At least now the test isn't failing anymore, so the huge red sign is gone from the screen. Okay, let's continue for a little bit. So we have like a big, huge if here, And like it starts all the way up here actually and spans all of this. We can already sort of see what it has to do with, because all of this mentions the quality thing a lot. So, I mean, I think we can just quickly, without reading it into detail, we can extract it quickly as something that handles the quality. Maybe we can even say update the quality. It seemed to change it in some places. We're factoring it out, sure. It again wanted to give the index, which is understandable, but we don't want that. We want this here to be extracted as a variable. All of the 18 occurrences. This way we can take this, put it up here, take this thing and grab it out of there and put it in here. You also notice something else that sort of helps me at least gain confidence so that I don't need tests, is all of the changes I'm making is provoking an error that I can only fix really in a way that is correct. Like there's no way to resolve this error short of writing like null or something weird that would not lend itself to having only the correct solution working. Now these two go pretty much together. So we have something that updates the quality and something that updates the selling. That seems reasonable. This is much easier to get like a quick bearing of now. Oh, this is actually called update quality, which makes me feel like that's not the best name for this. Of course, this one is public, so we can't actually change it, right? It's outside of the scope for refactoring to change anything that we don't have access to. So we could imagine someone is actually using this class somewhere else that we don't know. And if we change the name of this one now, then their code will break. And we're not allowed to break anybody else's code. We're actually not allowed to break any code while refactoring. Okay, let's see what else we can do. So we have this huge method here that nags me the most of all of the things, because it has blank lines, which already suggests that we can do more stuff. And so let's look into that one. First of all, I'm thinking we could start from the small ifs in the innermost thing, starting sort of a bottom-up thing, and then expanding on how the quality will look and how the functions will be. This thing here we can extract. It's very small. It seems to be just checking that the quality doesn't go beyond 50. So we can extract that to increase quality. How do I say don't do it with what? Keep the original signature. Before it had this signature and it wants to give it this signature. No, keep the original. I mean, here it's sort of trying to help us. I sort of wanted to just not have the IDE do any work and do everything myself, so we know what's going on. Because the people watching may not have editors that are as powerful as IntelliJ. Unless everybody does, and I just don't know about it. So we have increased quality now, and it's called here. Now I did notice that this is actually doing the exact same thing. But for the sake of argument, let's say I couldn't remember or I didn't know. I would look at this one too, because that's now the innermost thing. And I would be like, okay, this is something we can extract. So I would again try to call this update increase quality, because that's a reasonable name. And it would be like, you have a conflict. Show the conflict. That's not the conflict I expected it to show. Well, in any case, it's telling me that I have something that's completely similar. Hello there. Your fan? D? So having this, so we realize that this code is actually the same as this code. So we can just call the same function. That should be fine here. Let's give it the same item and then a semicolon. Good. Okay, so let's look. This seems to be the innermost thing now. I sort of wanna, in my book, I have these rules that sort of dictate where you should do refactoring and how you should go about breaking up stuff like this without necessarily having to read all of it and understand it deeply, because that's gonna be time consuming. One of the rules say that if we have an if, it should be the first thing in a method. And that naturally means that when we have something like this, we actually need to just extract it. What I'm noticing is that the way it differs from its sibling is that this is farther in the future, it would seem. If seln is larger, then it's farther in the future. So we could extract this to be increase quality if far from expire, far from expiring. Let's call it that. Any tips to improve? Practice, 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 practice. Programming is something that your hands learn more than it is something your head learns, I feel like. And there is no substitute for just sitting down and just trying everything out. Trying to be creative, finding exercises, seeing other people do tricks and being inspired to try to do them yourself. I would love to say it's just something you can do like the Matrix, have a thing plugged in your head or read a book and then you're good at coding. But I've met no one who wasn't good at coding who didn't do it for a lot of hours. I hope that's helpful. In the same manner that we just extracted that one, we can also look at this one. This one just has a closer expiry date, so we can just extract that. Control that one. So this would be increase quality if, what did I call the other one? Far from, close to? Close to expiry. Keep the original signature. There are no shortcuts, unfortunately, to coding, in my experience. So now that was actually a bit of a significant deleting of line breaks. So these line breaks were put there by the original author of the code who felt like this was a thing and this was a thing, and that made sense. But now that we've extracted it, it doesn't actually make sense anymore. Now it makes sense to group them because they're very closely related, having the first, I don't know how many characters, 17 characters be identical. Oh, this is gonna bother me. They're not named like in the same way. Let's rename one of them. Was that shift of 6? Yeah. Expiry. Okay, cool. So we still haven't changed any of the behavior of the program. We've just extracted some method and introduced some names in extracting the methods. Okay. Let's continue then. The innermost thing now is this thing. So this, I'm spotting that it has to do with a specific item called backstage passes. So we could just this, and it has to do with increasing the quality for the backstage passes. So we can extract this too and say increase quality of backstage passes. Combine these two methods, I'm assuming you mean, Kiblowski. They're doing different things, and because they're not completely identical, I don't think it makes a lot of sense to join them. I'm imagining you'd want me to replace this with an argument that we could pass into it, and that I can see the merit of that to reduce the duplicated code that it feels like we have. But the problem is that would lead to us having this be 11 and this be 6. And up here, 11 and 6 doesn't really tell me anything. I mean, what are these numbers here? Whereas the method names currently tell me exactly what's happening. If we're far from the expiry, then it increases the quality, and also if we're close. And this also shows me that these two both happen, so I don't accidentally join them to become one thing. So I actually like currently that it's this way. They could be descriptive constants, but what would the constant be? Far from expiry and close to expiry? Like they could be this thing? That's fair. That's completely fair. We could even do that right now. That's not a bad refactoring to do. Yeah, I don't know. We might join them at some point. They're not bothering me right now because they're just so short, and there's really no risk that I'm gonna make an error in one of these because it's 2 lines of code, really. And I feel like don't repeat yourself mostly should help me not make errors, otherwise it's not helping me at all. We might do it later. I'm not saying no to anything. Okay. So now we have something here that has a blank line because this was clearly separated from this. And we actually have an interesting situation here where, well, I mean, we still have an if here, so I guess we could just extract that one. We could just say, what is this doing? Well, it's updating the quality, but it's updating the backstage passes further, is really what it's doing. So we can extract that too. Increase quality. See, now we have an interesting thing because it's saying it's already defined in the class. And I remember making that earlier because it's this one, increase quality. It checks if something's less than 50, and if it is, then it increases the quality, otherwise it does not. So they're nearly identical, they just differ in this specific one. So I guess we need to give it a different name for now. We might end up actually unifying those because they're so closely related. Increase quality, including backstage passes. Something like that. I don't mind having long names for things that are only called once. So things that we call often, like the increased quality is actually called quite a bit. That should have a shorter name, but if it's called only once, then just give it a long name, that's fine. Be more descriptive. Okay, this is now the innermost if that we have, and it seems to be doing, this knot is very hard to spot in my eyes. It just disappears and says, if it is the hand of Ragnarok, but it is not that. It is anything but. So this actually decreases the quality. We can express that. Decrease quality. I didn't spell that correctly. Decrease quality. Why did I switch to doing that casing? Keep the original signature. Oh, it's telling me that we have another case of that. Well, now it's sort of spoiled it. We were going to discover that later. Let's continue with that one. Do the thing that finish the thing that we started. Makes sense. You can easily get lost when doing refactoring and going down some rabbit hole forever. But I like to finish the method that I start doing. And once that is down to a level that I like, then I'll move on to the next thing. So this is saying if it has quality, decrease the quality. Okay. Decrease quality if item has quality, I guess. That is at least the best name I could come up with for something. I don't know what that would, what else that would mean. Okay, so we can see here that we also have the this code up here, it's only decreasing things that are not, again, this not really disappears in my eyes. That is not the age debris, and is also not the backstage passes. So that makes sense because the backstage passes are handled specifically down here, but I guess the age debris also doesn't count. In any case, this method now starts with an if and is less than 5 lines. So for now, I think it's fine. I would go for this. Can we just join this without it going over the limit? Yes, we can. I like that a little bit more. So now it's very clear that this is 4 lines of code. Cool, and we can move on to the next biggest problem, which would be this method, handle expired. This is now the longest method of the program. So we do the same thing we just did. We start from the inner thing. This decreases the quality, it seems, so decrease quality. It's telling us it already has it, and that is because we did the same thing. I guess we could, if we were in doubt, we could extract this as decrease quality temp to show that we know this is not the name that it should have. Skip, don't help me. So we currently have that method here, and we know it's conflicting with something, so we could just cut it and move it to where the conflict was so we can compare them. Now side by side we can see they're actually completely identical. So what we can do in this case is just replace this thing with a call to the other one here. It doesn't return anything, so in that case we don't need to return. And once we've done that, we should be able to just use the IDE's inline method. Did I miss it? Inline method here. Inline and remove the method. Yes, that's exactly what we want. So now the temp method is gone and it's doing the same thing. But we did it in a safe IDE guided way. It does not like this expression, it would seem. Why is it yellow? Oh, yeah, I guess, okay. That's pretty funny. Well, it doesn't matter for the refactoring, so we're just gonna keep it as it is. The innermost thing now is this thing. So this seems to decrease the quality if it has quality. Again, this triggers in my head that we already did this. So decrease quality if has quality. No, did I not call it that? If item has quality is what I called it before. Let's move it up to where it should have conflicted. Here. Yeah, and they're doing the same thing, so we can just put this one because it's a void thing, delete the body, give it the item, and then inline the method here. Inline and remove. Go. Let's not take up too much white space. It doesn't really add much here. Okay, cool. So this thing we can look at, it seems, is just increasing the quality. By now I remember that we have an increased quality that says if quality is less than 50, then increase it, and that's what this one is doing. So we can just put increased quality with the item here. That should be fine. The innermost thing now is this thing. It's saying if it's not the backstage passes, then decrease the quality. Otherwise, the quality is equal to 0, as it were. So this seems to be handling the backstage passes, is really what it's doing. So it's handling expired backstage passes. And now that we've given it this name, it really doesn't make sense to have... Oh, I guess it's not handling only backstage passes, it's handling either the backstage passes or the other thing. This is really what's handling the backstage pass. Are we back? Okay, so in that minute, I guess the only thing I really realized was that this was not handling backstage passes. This was handling anything that was not aged free. Because it handled both the backstage passes down here and anything else up here. So really the only thing that it's not handling is the aged free. Okay, so let's pick up. Yes, where were we? Now we have ifs with elses, and we don't really have any, let's call it just ifs anywhere that's not at the start of a method, which is nice. That line break sort of nags me, but we'll get back to why I can't really delete it yet right now, it would seem. So here we're actually in violation with another one of my rules, which says that we cannot both pass something as an argument and call something on it. And in this case, we're not calling, we have public fields, but that essentially is the same thing. Or at least for the purpose of the rules, it's the same thing. So really, we cannot do these accesses. We actually need to extract these. So let's do that. This one, there are different levels of abstraction is what we'd say usually. So let's extract this one to be actually increased quality. We already have increased quality. That's interesting. We have it. But the other one is different. Keep the signature, don't do a replacement. So let's get the thing that we just made, increase quality temp here. It just puts me somewhere in the code. So these are the two that conflicted, which is interesting because this one seems to be a child of this one. So this one has an if in addition to what it's doing. So we can rename this to give it a longer name to signify that it's a more specific thing that's going on. Quality if not max. I'm guessing it's because that one is max. Now this one is not temp anymore. Now this is actually the permanent name. And that means that we can actually just call it from up here with the item like this. Okay. Let's continue with the method that we started at, this one, where we're actually calling something and we're passing. We're still accessing something on the item and we're still not allowed to do that. Now this one doesn't make any sense. So we can go and say, well, I mean, see, this is interesting. This is when we can either go and extract this one into its own method, or we can go and push this code into the item class, which would be way more interesting. I think maybe we should just start doing that, maybe. The code is already fairly readable now. It updates the quality, updates the sell-in. I think it's going to get a lot better if we just start pushing the code into the classes. So let's do that. That's also my favorite part, pushing code into classes. Let's see, let's start with the small ones. Let's take the actually increased quality here and let's put that into the items class. So what I did there was I started by copying it and then we're posting it in here. Now this can't be public anymore. So for now, we're just gonna make it package public or package private, as whichever one you wanna call it. Now it doesn't take the item anymore because the item is itself. And so that means since the argument is being replaced, we just put this everywhere. Now we can go back into this code and we can actually just say item.increase quality here. And we don't need to give it any arguments because the argument is itself. And now this one is only one line. And as we do often in the book, if it's only one line, then we can try to inline it, which we will do here. So now we have it inlined here, and we also should have it inlined the other place here. Yes, good. Actually, we're noticing now that this one, for instance, could also be pushed into that class. So I think we should try and do that too. that makes sense. See, in actuality, in this kata, I think it makes a lot of sense to do this right from the start. But since that's against the rule, I'm also reluctant to do it. So the argument is replaced with this, and then we can go back to the original method and just call the new method, but on the context that was the argument before. So that would be item. And then that's actually it. And so now we can go here and we can inline this method, changing it ever so slightly. Now we could go and do it to the next method, this one. Would make sense. So we can go down here. Thank you, Klobowski. And we copy this one, there's no argument. Now it gives us errors. You'll notice that I use the errors from the compiler a lot to guide my refactoring to make sure it's safe. That's pretty important if you want to do something where you're writing, let's say fewer than optimal tests. We need to gain our confidence from somewhere. Okay, let's do that one too. Why not? We push it in, we make it public, we delete the argument. So now we put this and we put this. And then in this one, we can just call the new method here, and then that's it. Now actually these are just one line. Did I not inline that before? I guess I didn't. I'll do it now. Let's inline it. Cool. Okay, good. Let's see what else makes sense. This is also very, oh well, it has this one. Let's see what else is small. Well, this one is actually pretty small. At least what we notice is that all of the things concern themselves with something that is in item. And when everything calls something that is in item, it probably makes sense to just push that thing into item as well. So let's do that thing. Let's remove this. Can I do, it doesn't, okay, I can't do multi-line select, at least not in the way that I expect. Okay, new editor, bound to be some weird things. Let's go in here and call the method on the item that was the argument before, and then remove that code. Cool, now we can inline this thing. Now we have the same case here, see. It also just calls things that are an item, so that suggests to me that this wants to live in the item class. Did I just cut it? Yeah, that was not intentional. Here. We keep it there, we copy it. That's important to keep the code in a green state all the time. Cutting it was a mistake. Okay, we remove the argument, and how can I do this? Okay, like this. We put this instead of the argument, and then we can go in here, and we can just say item dot call that method, and then remove the body. And now it should compile. And that means this thing can be inlined like that. Good. See, this method is different. It doesn't concern itself entirely with just things from item. It concerns itself with this method, which is from the current thing. So we can't actually push that out yet. We can't even take that method and push it into, because that also concerns itself with something in this class instead of an item. Decrease quality, however, we can push into item. So let's go in here and let's look. It's not private. It doesn't take an argument. See, that one I would have missed if I didn't make it a compile error. But the compiler misses nothing. Good, let's copy the name, hit it back in here, and then delete the body. Oh, it's called on the item. That's fairly crucial. Now we can that's not inline, that is inline. We have another thing now that concerns itself with item. So we push it in, delete the private, delete the name there. Yeah. Replace the argument with this. go in here, call the new method on the item, and then remove the body. We then inline the method. Boom. Like so. And slowly but steadily we sort of bubble all of these things up. And see, now everything here concerns itself with the item, so we can just take this, we can copy it. Even if we can't quite see whether all of this has to do with item or not, it's fairly easy to check. We just paste it into item. We remove this thing and see, can we make it compile by just putting in this? Whoa. And in this case, it seemed like yes, we could. So we do this with the item dot, and then we remove all of that code. We have now something that has only one line, so we inline it. Good. Let's see, what else do we have? Oh, this is actually becoming a very short class now, which I like a lot. It's a lot easier to see everything that's going on here. Let's see, this down here seems to be only item things, so we can extract that one, or push it into the class rather, into the item class. It's not surprising that a lot of this is pushed into this class, because a lot of the functionality was about the item and was sort of, yeah, concerning itself with that object already. Let's remove this. Good. Now this is just a single thing. We can inline it. Now this one only concerns itself with item. Let's see, we remove the private, we remove the argument. I hope this is getting repetitive to some of you, even though it is going a bit fast, I imagine. But the point is, we're just doing something easy a lot of times. Small, tiny steps, not this item. And slowly we're transforming the code. I'm hitting a lot of keys. Now this one is only concerning itself with item, so we can take it and we can put it into the item. Here. Oh, that was a little much with the white space. Let's get rid of that one. Let's do this. Okay, we take the name, go back, put item.this one, like this. Now it's just a single line, so we inline it. Now this one, finally this one concerns itself only with stuff in items, so we can take it and we can put it into the class here. At least I hope so. I think so. Like this, we take the name and we go back in here. Then we say item dot here and we remove all of that stuff. Good. Now this is just a single line, so we might as well just inline it. And now this code in Gilded Rows is just looping through and calling two methods. And in fact, they're both called updates. So really, we could just call one method that's called update. That would be fine. I don't know if we want to go that far. It kind of makes sense. It kind of does make sense, doesn't it? Let's just for one last time, show how we push code into class. So we take these and we say extract it to a method that just is called update. It takes an item. I like that it did the item this time. And then this update now only concerns itself with things in items, so we copy it and we put it in here. We make it not private, and then we remove that thing and we type this here, and then we call update in here, item.update, like this, and we then inline it. Good. See, this is a class that concerns itself only with the items, which is its own data, that is. So optimally, there would be a very strong coupling between what the fields are and what the methods are concerning themselves with. And in this case, there certainly is. So Let's look in the item. It got a lot longer from that transformation. I'll just remove these. I don't really like those. So it got longer, but still many of these method names are very explaining. So it's fairly easy to read this code. I think still we can do some interesting stuff. So we've already broken it down a lot. I think the most interesting thing now would be to start eliminating some of these if-elses. This one, for instance, seemed to be a little bit bothersome. This one too, because there's another rule in my book, and now we're transitioning into the slightly more advanced stuff. The rule says, don't use ifs with elses. And we certainly do have a lot of elses here. Else, else, else. Yeah, that seems to be that. Good. Let's see how we eliminate one of these elses. Well, really, an else is a sort of an expression that we have a type code of some sort. And it might not be very obviously a type code. A switch is obviously a type code, but and a Boolean is a type code. But in this case, the type code really is hidden behind the name, which is sort of iffy in itself. So what we want to do is we want to make these actually into type codes. So really we have a type code called aged brie. And in this case we're doing something for not that, but that also means that we're doing something for that. So let's look at how to make aged brie into a type code. Well, we could do this by just making it a, what do we call it? An enum. Let's just make an enum up here. And we'll call aged brie. Now we'll call it, yeah, aged brie. Aged brie, and it has the values is aged brie. Maybe we should call it is up here, and then call it yes and no. Those seem like decent values for an enum, I think. So this is aged brie is now an enum that we've just created. We also want to put that in a field. Essentially, we're front-loading the responsibility of figuring out whether something is an aged brie or not. So down here, we want to make a field for that. So is aged brie. And it has the, let's just say is aged brie, that's a decent name. Now we need to assign this thing. And given the fact that we know the name doesn't change, we can actually just take, we want the expression in the aged brie to correspond to this value. So what we can do is we can say is aged brie equal to whether that is true or not, to be is aged brie dot yes, otherwise is aged brie is no dot no, like that. And so now we can actually go here and say this should be not equal to the yes value. Let's just take that one here. That should be the same thing. We've not changed anything. We've just introduced a level of indirection. So we're checking on the same thing first. We still have the not, and then we're assigning it to something that's essentially a Boolean. We could actually have just used a Boolean for starters, but what I want to do now is, because we know the name doesn't change anywhere, and we can check that in multiple ways. What we could also just do is we could make this final, then we're sure there's no way it's changing. We're using the compiler again. What are some cool things you can build with Java? You can build anything with Java. It's Turing complete. So there's nothing computable that you can't build. Minecraft was built with Java, so that's a pretty cool thing. I guess iPhone apps would be tough to create with Java. I don't know if that's possible. Okay, so we have this variable now. We know that name doesn't change, which means we can just move this check straight up to the constructor. right here. So we're doing the same thing we have been all along. It's just we've moved the checking to as early as possible. And that is when we get the name of the item. I like to build all sorts of things. Mostly though, my interest is actually in designing platforms and libraries, if we are talking code, because I like figuring out cool ways to make people not make mistakes and make it practically impossible to make mistakes, which I really like. I'm seeing actually another cool feature that I was going to zoom in on later, but I'm seeing that IntelliJ sort of got there before I did. I wanted to talk about the fact that all of these fields used to be public, because otherwise Gilded rows couldn't actually access them. But now, because we've pushed all the code into here, they're actually all private now, which is a super nice way to keep our interface clean. So even though we've pushed all of these classes into here, if we actually look at what the interface of the item is, it only has update and toString. And toString it had already. And that's it. So we haven't even polluted the public interface. The only reason name is still public is because it's used in our test case, which currently does nothing. So really this could be private as well, but we would need to change the test to rely on the toString instead, which would also in any case be a better test case. We've seen how to do this for age debris, and I'm thinking probably most of you can figure out we want to do the same thing with the backstage. So we go up here and we just make a thing for is backstage passes. Is backstage passes, yes or no? And we do the same thing here. Can I duplicate? Nope. Okay, we'll just duplicate the other way. Here with the lowercase I. Is backstage passes, we can do it as late as possible. Down here, whoop, here. Is backstage passes is equal to this check with an if that says is backstage passes yes, or is backstage passes no. And then we can take this, preserving the no or not. We can go here and say backstage passes not equal to yes. And then we can take this. We already know the name doesn't change because we tested that by making final before. So we can push this up here to as early as possible in the same manner we did the age debris. Okay. Now we actually also know something different because this long string is actually tested multiple places. Why not just Booleans? It could just be Booleans, and that's completely reasonable. So saving, not doing this and just having them be true and false, but doing them as enums make something very clear that Booleans hide a little bit. So I'm going to do something with these in a little bit. But you could totally do them as Booleans. That would be fine for now. Maybe we should do one of them as Booleans just to show that it's the same thing. For right now, I'm spotting that this name, is also checking on the same thing, so I can change that to the same check that I had below. I can say is backstage passes equals yes. Here. And we also have that down here, so I can take this, I'll just copy it. That makes sure I don't type it in wrong. Not that there really is any, and you can have a not in front of that. Do not need the parens, we'll just push it straight in. Is age debris, we also had that already. Do we have it here? This is not equal to yes. That is the same. That is good. And yeah, so now the only thing that we actually are checking on with a string seems to be this name of Hand of Sulfuras. So let's do that one as a Boolean. That will be fine. So let's go. Oh, that's not duplicate line. SD? Yes. Boolean is hand of, what was the name? Sulfuras. I'm guessing that's some sort of gaming reference that I'm not getting. Does anyone know what the reference is? It's from WoW. Oh, okay. Cool. See, I figured it was something. Thanks. So this one then would just be still with the not there. And you know the name doesn't change, so we could push this to as early as possible up here. And then we also saw that it was used in this here place. Like this. Are all of them weapons from Warcraft? World of Warcraft? Is aged Bree backstage passes? I would have expected aged Bree to just be cheese. Okay. Yeah, so now we have these. I guess someone pointed out very correctly that we do have some magic constants, and yeah, they're not optimal, so we can just replace them with constants. Wait, introduce constant? Yes, HB, that's fine, that's good. What does it want to call this one? What? Did it say it couldn't? Or is it because I'm not done here? Yeah, yes. I don't know what I clicked. Good, it seemed to get out of the mode that it was in. Introduce constant. See, this one I would probably just want to call backstage passes. And this one I would just want to call sulfurous. Let's extract it to a constant. And let's get the name simplified like this. So now I called it hand of. Oh, it's not called hand of sulfurous. Let's rename it then. Is sulfurous. Good. It's shining through that I don't do a lot of programming. Click enter, thank you. You could change line 98 quality to 0, right? Oh yeah, to the, well, oh yeah, okay, so you're doing something else. This one, I'm guessing you're meaning. What IntelliJ is complaining about is that quality minus quality is just 0. Unless what you're suggesting is that we change this line to minus minus. In which case, sure, I don't mind that. We also have another place where we have a long version plus plus. This one would just be plus plus. Although those aren't really, I wouldn't call them refactorings because they're, well, I mean, I guess they are refactorings. Sure. Like this. So now I hope we don't have anything that this one is annoying because it seems to be a magic constant. So it is max quality. Increase quality because it seems to be, we had like an increased quality somewhere that seemed to indicate here that it was the max quality. Good. And do we have, yes, these are also magic constants. Let's introduce a constant for far from expiry. Did I spell that correctly? I hope so. This one would then be close to expiry. I haven't tried Kotlin actually at all. I've heard good things about it though. So it's somewhere on my list of languages I would like to try one day. And the list is as long as my reading list, unfortunately. It seems like a luxury problem that there are so many nice things I would like to play with. Now, this one actually sort of catches my eye because it's just one line and it's not really doing anything interesting, and it doesn't really have any arguments. So I guess we could just inline this one, why not? Yeah, I'm guessing that before this had the issue of being on the different levels of abstraction, but now we're not calling or passing anything, so that's allowed now. Good, 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 good. We didn't actually get rid of the else's yet, and that was sort of the whole mission, one can say. I guess this one, though, also sort of is eye-catching because it's the only thing that has some sort of Boolean conjunction thing here. And that suggests that there is a connection between these two. So we actually want to extract that connection out into a method. And what it seems to be is something that's not brie and also is not backstage passes. So not brie and not backstage passes. You will also notice that I don't spend a lot of time coming up with great names, and that's because usually the naming sort of is a lot easier the later one does it, because we learn stuff about this program while we're going through it. Like, we haven't spent any time reading this code really, but we already know a lot of what's going on. At least I feel like I've gathered a lot of bits here and there about how some of the things work. And when we move methods around, sometimes we inline them, the names come and go very quickly when it's in this very fast-paced refactoring stage, at least. Okay, so let's look at this aged brie thing, because that was the first thing we saw where we had an if-else. This one specifically is what we're looking at. So when we have something that's checking against a, what's it called, an enum, we can actually just replace that enum with what we call it. Okay, I'll start that sentence over. An enum is what we call a type code. That means it's encoding something, some value. The problem with enums is that they typically end up spreading out their sort of functionality all across the program. In this case, you can see that we actually check against this variable multiple times in different contexts. And this is a small sort of Kata example, so it's not that bad. They're both in the same class. But this could easily be spread all across an application, and typically are. So enums have this delocalizing way about them, where you just scatter stuff that has to do with them all across the code. So what I like to do when I have enums like that is turn them into classes instead, because classes tend to localize things instead of decentralize things. So let's look at how that looks. The first thing we do is we make an interface that is called isAgedBrie to temp something. It doesn't matter, this name is temporary, we're going to rename it later. So now this needs to be corresponding to that one. So we introduce methods for each of the values in the, that's not duplicate, that's duplicate. And they're yes and no, and they return boop. That's not how you write that. I've just been writing a lot of TypeScript lately, and that's how you do return in TypeScript. Good. Now we also create classes. Class. This one would be, what should we call it? Just yes? Sure, why not? It's important that it implements, it's important that it implements this one, isAgedBrie temp here. And that means we need to implement the two classes, or the two methods. The yes one is easy, return. Well, since this class is called yes, I think it's fair to say that it should return true for is yes and false for is no. These need to be public, is that what it's complaining about? Because they're in the interface. Like this. Good. Yes. We also need one for no. No. Good. So now we have these classes, they correspond to this very simple enum. And I know it's a lot of lines, it looks like a lot of code, it looks like we're bloating everything, but eventually this will all just melt away and become beautiful, trust me. Okay, so what we do now to find all of the places where we're using this one across an entire application that can be sort of difficult, an easy way to just have the compiler help you so you don't make as many mistakes is just renaming it. Because now everywhere we do use it, the compiler is going to be like, something's wrong. Yes, see, it's like something is wrong. So what we do is we go through and we replace everywhere the type is with our new type. And everywhere we use a value like this, we just say new yes, because that's the class that we made. And this would be new, no, whoop, don't know what I clicked there. I don't think I want to know actually. New yes, new no, and we have some errors down here. The compiler down here with the list would give us all of the places in all of the files. Switch the booleans to no class. I didn't do that? Oh. Yeah, that would have been bad. Thanks for catching that. Okay, so in this case, we're checking against if it is yes, and then we're saying not, so we can replace this with an expression like this. And in this case, when we have an equals equals, we can just say is yes, because that's exactly what our method is doing. And we have the same thing down here. This would be not equals equals, like this. And then we are checking on equality of yes, so we can just say is yes, like this. Did I mess up the parens? Yes, I did. Good. Good, everything compiles. Great. What we can do now, and now is when it gets really interesting, is we can take this expression that is concerning itself with the is age debris, and we can actually push this into the class. So if we copy this method here and go up here, we can actually add a method here saying void, what was it called? Let's just paste it into one of the classes so we know what the name is. It's called handle expired. And we know how push method into class works already. It has type void, has no arguments, and it has no body, like this. This then needs to be public, like this. And we can take the same thing and paste it down here. Good. So now we've just pasted the method into both classes. We have two ways of fixing this now because two things need to happen in parallel. We'll do this one first, so follow the way that it's described in the book. So what we do up here is we take the value of this one. Is age debris is actually itself now. So it's calling itself really, and we do that down here as well, which means we can take the value of this true and just inline it here. And now we have something that's not true. I know what that is, that's false. And if false, so all of this just disappears, right? That's just gone. In this case, we take the value of is yes, we put in false, we have not false, which is true. And again, the if just disappears like magic. We can now take this code and go down to where we took it from. Where did we take it from? We took it from here. And we can insert this and say, instead we're now calling this on the isBri method, or isBri class, isAgeDebris class. So we can remove that and we can take this code and we can inline it, because it's just a single line. If that was a little fast for somebody, don't worry, we're gonna do it again. Because we have backstage passes also, that has the same sort of structure. So we have this if, and we have the enum up here. Oh wait, are we actually in a position where, no we're not yet. Okay, cool. So we'll wait. Now we're not using this enum yet anymore, so it's time to just clean up a little bit and take the enum and delete it. There's no reason to have it. It's also telling us that we're not using the is/no, but that seems to be a coincidence right now. We could remove it, and I'm fine with doing that. That also means we can remove it from all of the subclasses, which is super nice. So cleaning up a little bit, that's what I said. Some of these things will just melt away very quickly. We can remove this one, we can rename this one to its permanent name. Now, we don't need the temp anymore, just remove that. So now we've eliminated one of the enums and one of the if-elses. This yes is gonna conflict with the next thing I'm gonna do. So for now, we're just gonna rename them to something longer. It doesn't matter that much what the name is at this point. A is h3. Let's remove. See, that's a problem. See, now I'm regretting calling this is h3. Really, this should be called h3 status. Whoa, sure. This one could now be called is h3, and this one down here could be called factor rename not h3, which means I guess we could just have removed the is and then kept that one. Doesn't matter. It's just naming. We shouldn't get bogged down by it. We should just keep our momentum going, keep refactoring, keep making the fun stuff. Is backstage passes. Let's do the exact same thing once again. We make an interface. We call it is backstage passes. It's a long name, I'll just copy it. Underscore temp to show that it's a temporary name. We give it is yes, which is, that's not where we write it in Java. Boolean. And duplicate, and no. So now we have a method for each of the values in the enum. So now we can make classes for each of the values in the enum. So in this case, we'll call them backstage. We'll call them yes and no again. Let's follow the same schema that we just did. If it works, don't change it. Okay, is yes and is no are trivial to implement. Is yes is true. And I realized the irony of saying they're trivial when I just made a mistake in them just minutes ago. They are fairly trivial. It is difficult to mess it up when you're not streaming. And I'll not make the same mistake that I did before. I would be tempted to put all of them into one enum typed h3 backstage passes. So yes, I see that's actually a good suggestion, but it uses something that that you know, and we will probably get there from this code. But until this point, we couldn't actually have guessed that these were connected in any way. They could be completely unrelated, and a lot of times in code that sort of happens under the radar, and it's only once you have them right next to each other and realize, oh, they're all dependent on the same thing, that's when you can join them. So I totally get how you got there, and it's a good change, but we weren't ready for it until basically now, and now we're doing something else. But we will probably get to that. It's a good insight. Okay. Let's see, let's use this thing now. So we'll do the same thing we did before. We'll just rename this one, and it tells us red things everywhere we're using it, and also the compiler is eager to tell us in all the ways we did something wrong. Lovely compiler. This would just be new, yes. This would just be new, no. And the next error is down here. Well, we're having equals with a value, so we just say is yes. And down here we have a not equals, so we'll replace that with an actual equals. because now we have an equals equals with a value, and we can just say is yes. And we have the same thing there, so I'm just going to copy it. That should be fine. Good. And now we have the classes. We are actually done with the enum. It's gone, it's unused now, so we can remove it. Again, we have that the no was never actually used, and that's just what happens sometimes. At least it didn't take us that long to write. So what we were doing all this for was for this specific if else, because the rule said no if with else. So we can just take this method here, copy it, and then put it into the yes. Here, we'll remove the private because it actually needs to be public, and we'll remove this with this. Now, this is just calling that one, so, oh wait, that's too early. We need to do some stuff before we do that. Because we need to copy it. If we start inlining and then copy, then it's not going to be a safe refactoring anymore, and we're going to break stuff that we didn't intend to break. So that is not good. Just be very careful with that. Preferably just copy the source and paste it in all of the classes before you start mucking around with it. That's probably the safest. Okay, so we now have this one, and we can take this value and we can put it in here. So we have not true, which I know what is, it's false. And when we have if false, that just disappears and everything is nice there. In this case, we have this one being false. If not false is true, so the rest of it disappears. And again, the else if just melts away. We didn't call it yet, so that's the next thing we should do. Let's go down here and call is backstage passes dot handle that thing. And then let's remove all of that. In this situation, this is just a single line, so we inline it. Good. We got rid of all but one of the if else's. That's quite good. Okay, let's see. We have a conjunction here because the last if else is actually determined on the conjunction. Let's just have a quick look down over this. I think we should rename these to something better than yes and no, and we should also rename this one. Let's just do that now. Like this. Let's rename the yes. What was it? Shift F6. Yes, okay, good. Backstage passes, and then this one would be called Shift F6, not backstage passes. Like this. And yeah, that's good. I kind of want to rename this one too. Now that I know the shortcut, it should be quick to do. And then that means we can also rename this one to, that was not the right key binding, hotkey. Do we only have this else left in this file? Yes, we do. So, time to eliminate it. We have a conjunction here. So, we can actually take, wait, we don't want the conjunction to be extracted, do we? We can take this conjunction. Well, they seem connected here, which is interesting. That is interesting, because does that mean that it is time to actually look at whether they can both be true? That just feels a little bit premature. I feel like we should be able to just extract this one, but I still want to. Let's just follow the rules, don't ask us that many questions, just go where everything takes you. So let's push this code into aged brie, I guess. Which would be up here, aged brie, put it in, make it public, and this is gonna be this. And then copy it before we make too many changes and paste it into the other one. Now we can put it into the interface. It would be a Boolean returning thing here. Good, now it's not unused anywhere. We have the value of is true, so we can just put that in there. If not true, I know what it is, that's false. If false and something, then it doesn't matter that there's an and, good. In this case, we have if not false, wait. Yes, not false is true, which means we can reduce this to just checking whether the backstage passes are good. Okay, and now we can go down here and we have there. And we just return the value of calling this on is aged brie. And then the rest disappears, as did it before. Let's refactor that up there. Cool. Cool, cool, cool. Okay. Yeah, that's nice. We can actually take, this whole thing hinges on whether something happens in the aged brie. That's the source of this else happens to be something that is connected with the aged brie. So I guess we could take this too and push it into the aged brie code class. Here. Okay, we make it public and we make it this. And then let's just copy and paste this code and put it into the interface up here. This is a void function with no arguments. Good. And in this case, we actually just have this thing here. And we know that it's just false. So we can just take this and put in. So we say if false, well, that's easy, just remove it. In the other case down here, we don't know what it is. It's just a single line though, so I guess we can just inline it down here. Like that. And now we can go back to the original code where we have the if else there. And we can just say is aged brie dot update quality, like that. And it's just a single line. Let's just inline it wherever that went. Cool, so we still have an if else actually. So people who noticed, we didn't actually get rid of it, we just moved it. But what we also notice is that this code here just hinges on the fact of the backstreet passes. So, and this hopefully also should start feeling repetitive, we can just push it into the backstage passes. In this case, this would be this. It's already public, so that's fine. And we take this code and we put it down into the not backstage passes as well. We can then put a void in here. Oops. Void in here, and then close everything. Good. We have the value of this true. That's just true, or it is yes. So not true would be false. Which means that we can just remove this if entirely. Down in the other case, this case, we also have the value it's false in this case. So we can take that and say if it's not false, then it's true. That means everything other than that goes away. And then we need to call this method also. It's called up here. That's where we got it. It's from the is backstage passes dot update quality. And that goes away. And we now have no else's left in the code, which I think is awesome. I love doing stuff like that. Cool. Cool, 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 cool. Something else that we can stop and do now that we should do once in a while is just check whether we have the ternary operators though. That is true. And I would love to get rid of the that's a very, very astute observation. Great find. We cannot get rid of the else's in this case completely because we need to actually these come in as strings, and we're not allowed to change this type because then we change something that's outside of our scope. And we're not allowed to actually modify what's inside string because Java coded in a way where we can't modify what's inside of a string. So we cannot get rid of them completely. So what I like to say is you can only have else's and ifs and switches and stuff at the edges of your program. That is, right when you get the data, that's when you're allowed to do whatever with it you like to parse it into data types that you have control over. And that's what we're doing here. The backstage passes and not backstage pass are the classes that represent the same thing, but we do have control over these. An alternative approach would be to make a new version of string that we could actually put these methods into, which would also be nice, but then we would still need the else's inside of the new string class. So you're allowed to have the else's at the edges, but it's a very good, good comment. And it's an interesting discussion. I would have completely forgotten it if you didn't point it out, so thank you. Okay, what was I saying? I was saying something. Yes, we also need to once in a while go through and clean up a bit in the code that we have, because we introduce a lot of methods. And that's sort of the intention, because that makes the code very flexible. We can just move these little Lego bricks back and forth very easily. But because we introduce a lot, that also entails that we need to remove a lot of them. So in this case, IntelliJ is actually telling us that these are not used. If we didn't know whether they were used or not, we can just remove them and see if we get any red lines in the code anywhere. In this case, because it's Java, it's red because it also doesn't allow us to say that we're overriding something that is then not overwritten. So we can fix that by just not overriding it. We need to do that in this case as well. Once we've done that, we now have no more errors, which means the method was unused, which confirms what IntelliJ was telling us in that case. The same goes for isTrue, so we can just remove that one. And now it's also nice, and it's telling us that isTrue here is also unused. And another way to find out if that is true is just to make it private. Then it's at least not used outside of the class, but we can also just remove it or rename it. Either works. In this case, this is also unused, this is also unused, and this is also unused. So now actually from the H3 perspective, all of the methods we introduced that had to do with the enum values are gone. They're just vanished. Which I love stuff like that, right? We introduced something, it felt kind of ugly while we were doing it, but now it's just gone. And we're left with just the nice things in the code. Yeah, I like it. Okay, let's see what else do we have in the code that we can move around. We have this one that also just checks on something in backstage passes, so it makes sense to just push that code into there. So let's do it into the first one here. We'll make it public and we'll make it this instead. Then we'll copy it before we do too much, and then we'll paste it down here. We need to add it to the interface. I'm guessing it's void because everything in this program is void. There's a lot of side effects. Good. Now in this case, it wants the value of is yes, and we know what the value of that is. That is true. And in that case, we just... So how long have we been out? Like a couple minutes, I'm guessing? I'm hoping it was no longer than that. So the only thing I did was I pushed this method into the class as well, as we had done many times. Since 21:29, yeah, so 3 minutes, okay. So what I did was I took the method, this one, because it uses only is backstage passes. So I just inlined that method and I inlined the is yes value in that. And so now we can just push is backstage passes dot that one. It is exactly the same thing we did with the other things. So this one goes away. It needs to stop dropping. That's super annoying. Damn. Now this one is just one line, so we can just inline it as we've done before too. And let's look across all of the ifs if anything is seeming like it's... nothing is testing on one of our 3 is values anymore, except this one. This one seems a little more, what's it called? Subverted? Secret? Hidden. Also, I'm noticing now, looking at this, that this is actually just calling that one. These are completely the same, so we could just go here and say, well, this is just decreased quality. In fact, removing that one, simplifying further. Good. So is your for us, and that's what we talked about. It's a Boolean. Booleans are actually just hidden type codes. So in the same manner we did before, we can just take this value and make it, we could make it first into an enum, which would be easy, and then do the same thing here. And I think maybe that's a structured way to do it. We can also go straight to Booleans. What do people think? Should we do it? Should we make it into an enum first, or should we just make it directly into classes? What do you guys think? Classes directly? Okay. Yeah, classes. Cool. Let's just make them straight into classes. Interface is sulfurous. It has an is true. Wait, that's not where we do the return value in Java. And is false. False and true are the values of the implicit enum Boolean. Class sulfurous implements is sulfurous here. And let's take these two and let's put bodies in them. Return true. Return false, like this. They need to be public. Yes, public here as well. Okay, and we need the one that's not sulfurous as well. And the only difference is that it's gonna return the opposite things down here. Good. Now we can go and say this is now actually that value, and we should get errors in the same places that we would if we had introduced the enum. So in this case, we need to do new sulfurous, and otherwise it's new not sulfurous. Not, did I call it that? No. That's not what I wanted to call it. Not sulfurous here. Good, and we get one error. Yes, thank you, compiler. We get one error, and it's here, where this would be dot is true because we have the not, and that's important to keep the distinction in mind. But to reduce to remove all of the confusion of it, we're just going to inline this push this method into the classes immediately, because then it will simplify away. What am I pushing? All of the wrong buttons here. Okay, let's put this one. I guess we'll have it be this, and then we'll push it down here, like this. And we also need to add it to the interface. Decrease. This has type void, so that's good. Now we can go here and we can say, well, we know what the value of this one is. It's true. So in this case, not true is false, and that means all of this goes away. In this case down here, we know what it is. It's false. Not false is true, which means the if is unnecessary, and we just decrease the quality like that. We can then go and call this method down here, and then we would need to call it on that one. If we don't call it on that one, we'll end up getting infinite recursion here, so that's pretty important. That would have cost us a lot of headache. It could have, at least. Okay, cool. Let's see, what else do we have? The confusion went away, that's good. Okay, let's look. It's starting to be fairly straightforward, the code. It's not that complicated anymore. Let's look if there's something up here. Well, there is something up here. We can do the cleanup because both is true and is false are unused, which means they disappear from everything. In fact, completely. This also very much shows you the structure of the initial code that we started with, because we've only taken safe steps that didn't change anything. So in fact, sulfurous is only used to determine whether to decrease the quality or not. That's the only way that it matters. We can also go and look at some of the other things. I'm curious as to where this is being called. Or maybe we just didn't remove it from the interface yet. Yeah, that's it. Yeah. So let's just remove it from the interface, which means it also disappears. And now we have no remnants left of the enums that were there briefly in the code. Cool. So now we can just look at the structure of things and say, well, HB had to do with handling an expiry and updating quality, which I guess are fairly general methods, because this also has to do with updating the quality. But it also has something else here. What are we using that for? Handle expiry item not aged pre. This seems to be an inappropriate name in this class. I guess it would be a better name to just call it handle expired without the I also. Because we know at this point it's not that. Also of backstage passes, that's obviously what it is, because that's the thing that the class is called. So we can remove that too. Okay, cool. Cool. And this is decreased quality is a decent name for this one. Handle expired, handle quality. Yeah, good. Okay, let's see, what else do we have? So what we can see, this one is calling into backstage passes directly. That's interesting. Because I was just about to suggest that maybe we can actually link the three now. They seem to be sort of linkable almost, but maybe they're not quite so, because a lot of things in here have to do with the backstage passes. So can we exploit that in some way? I think we would need to maybe push this one into that one. That would be an interesting thing to do. What else could we make it do? We could make it not aged pre. Yeah, I guess we can do that. Because we can take the code down here that is concerning itself with the backstage passes, and we can also actually push that into the aged pre. Let's do that. Let's just go nuts with this and see where we end up. Let's see what's going to happen. So what we are going to do now is we're going to push this variable into the not pre class, because I feel like that's where it's mostly used. What is the book you are demonstrating refactoring from? It's called 5 Lines of Code. There should be a link to it down below somewhere. It's the book that I'm writing. It's a down-to-earth introduction to refactoring. Okay, let's see. So the backstage passes, yes, that's what we're doing. Let's move it. Let's just take this variable, cut it from here, and put it into not aged pre. Which seems sort of silly at first, but I think, whoops, stop putting me places. But I think it's gonna actually be very useful. Yeah, let's make a constructor for this, not aged pre, which then takes the name, I guess. Wouldn't it need to do that? And then we can go down here And we can take this expression here, giving this the name. We can put it up here. There. And we have one error down here where it's saying, I don't know how to do this because the method was pushed away. So we can fix that by first extracting this into a method called private void increase quality of backstage passes here. And then we'll put the code that we just had. We'll call the method up here like that. And then we'll push this method into the aged brie class where we now have the backstage passes. Or not aged brie, that's where we have it here. Which means this needs to be public. This also means that we need to put this one, oh wait, we need to put that one into the other one as well, which we cannot do. Can we? No, we cannot. Yeah, we cannot do that. Okay, let's unroll. Step back a bit. That was not the way to link them. Interesting. That seemed very reasonable. Okay, let's see how then we want to link them. We're back to no errors. Good. Good. Okay. They feel so linked. It's curious that they don't want to be linked. Is aged brie, not aged brie. Oh, I guess we should start from the bottom probably. So this one is just a single line calling something else, so we can inline it, which we would have usually just done. Good. Now, how can we exploit this? Do we need to exploit it even? We might not need to. Well, we know that from here, only one of these can be true at any given time, which does mean we can link them. So that means that we want to link all of the not classes, in fact, somehow together is what we'd like to do. So what we can say here is this code is only true if it's in the not brie thing. So we can take this and be like, if do we need to actually do that? We don't have a class that determines this anymore. We could make a method for it. Would that be the most structured way? Yes. We like structure. We want to do the structured way. So here, we actually reintroduce a method we deleted earlier. Is not aged brie. We had it earlier, we never actually used this one, but that doesn't play any role here. Return false in this case. And down here, we want to return true. What did I do wrong? Oh, public. Yeah. Relax, compiler. I got it. Okay, because now what we can say is this stuff down here only happens if this one is not aged brie. Right? We're making something that we can see as humans clear in the code. Are we breaking any rules right now? No. We are just realizing that because they are switching, so this is not something that the book has rules about, because it's such a specific case that we're doing 3 equals on the same value. So it's not something I have a general rule for. But being humans and having and looking at this, we realize they cannot all be true. In fact, this one, if that one is true, then it's going to stop here and neither of these have any effect on anything. But if it's not true, then it could be this one, and that means these could still be true. So I'm just taking that insight that I had and putting it into the code, right? This code is only relevant in this case. Otherwise, wait, how do I want to say this? Because they're still going to be called. Otherwise, they're both going to be not. So we can just put that here and say, in this case, this is going to be false and this is going to be false. Because it cannot both be this value and the values that are here. Yeah, that should be true. Okay. Yeah, and we can actually say the same thing for the backstage passes. We don't want to do that directly, I'm guessing. Now we've introduced an else, which is interesting because that's what we're trying to get rid of. So let's take this stuff and put it into a method. We isolate it because it has an if in the middle of a method, and we're not supposed to have that. Now we're breaking a rule. Well, we have an if in the middle. We're allowed to break rules intermittently. We're just not allowed to deliver it before we fixed it. And we're about to fix it. This would be called initialize is aged free, check is aged free, initialize backstage passes, and sulfuras. Like this. Now we could take this method and we could push it into the aged free class because that's what it concerns itself with. So let's do that. Here, aged free. This needs to be public and it needs to, yeah, that's fine. Public, and this one needs to be this. And that's it. So we copy it before we do too much, and we put it into the not aged free down here. And then we also need to add it to the interface. Void, sure, it takes the string name now. I noticed. Good. In this case, we know what the value of this is. It's false. If false, well, that's easy. It just all disappears. In the other case here, we also know what it is because it's true, in which case all of the rest of it disappears. So the else disappeared again, which is good. That's what we like to see. And then this one becomes is aged free dot initialize the other two variables. And then all of that disappears. We need the name to be passed. And then in this case, we can just inline that one because it's just a single line. Yeah, like that. Okay, cool. We have the same sort of thing happening up here with the backstage passes, because if it's equal to this thing, then it cannot also be equal to this thing. So we can encode that if we introduce into the backstage passes the method that we also had earlier. Boolean is not backstage passes. And let's copy it. Let's put it in here. Let's make it public before I copy it anywhere. And let's return, in this case it's false, and in this case down here it is going to be true, like that. And then up here we have to say if is backstage passes is not backstage passes, then this can, we still need to check that thing. Otherwise, well, then there's no need to check it because it cannot possibly be solved for us as well. I think the knots in this make it harder than it needs to be, but they were in the code and we want to keep it as close as possible to what it originally was. So let's take this one and extract it to what? In that one. Initialize solve for us. Like that. And that concerns itself with the is backstage passes. So we can take this one and move it into the backstages. Here, let's make it public. Let's make this. Let's copy it before we do too much stuff to it. And then we also need to add it to the interface. Void initialize. Does it take the string name? I think it might. Yes. Good. In this case, we know what this value is. It's just false. So we can just put false here. We have if false, which disappears. In this case, we also have the value because it's true, and the rest disappears. Like this. And then we need to call it, obviously. Here, let's take this one, dot this thing here. With the name. Yeah, I know. Whoops. Like this. Stop complaining. And this one we can inline because it's just a single line now. And that looks good. Is not backstage passes is now unused again. So we remove it. And refactoring very much has this kind of breathing thing to it where we expand a lot and then we contract a lot and then we expand a lot and then we contract a lot. It's very cathartic just sitting here deleting a lot of code and then adding a lot of code, and all of it is small steps and it's all straightforward. Okay, let's see, what else do we have? So I kind of want to push more things in more directions somehow. But how do those directions affect each other is the question. Like, is solve for us, is that only used inside of backstage passes? I don't know. Let's see. No, it's also used down here, which means we would have to push this stuff into backstage passes. I guess we can do that. Let's try to join them again. I know it didn't go well last time, but this time I'm sure it's going to work. Okay, yeah, sure. Or, wait. We want it to go in there, so we should probably just put all of the references in there. That makes sense. So if we want this thing to go into the backstage passes, we can either replace it here or we can take the whole method. Where does quality come from actually? Oh, it's initialized with quality. Cool. Cool. Yeah, so let's just take this line then, and then we can first extract it to follow the method. Decrease quality. I hope we don't have that. skip it. Well, but I mean, okay. Well, let's just say that we realize immediately that that's the same thing, so we don't have to go through the whole thing and realizing it later, because we can just do it directly. Let's take this code and push it into the aged brie. And we're doing something now that's not specifically syntax directed, whereas most of the rest of the stuff we've done has been syntax directed, but this is actually directed by a higher goal, one that we know as programmers, not one that is in the code per se. Or I guess it is in the code, because we know that this has the is-solve for us, so we can move this in here. Let's make it public. Here. Let's have the same code down here, because we've just copied it, and then let's add it to the interface. Void, decrease quality. Good, this means these are good. Yeah, so we can go down here where we took it from, here, and say backstage passes dot decrease quality, exactly. Like that. Do we have Sulfuras pretty much isolated now? Yes, I think that we do. So now we can actually just take this variable and push it directly into these places. Here. Almost. Oh, this one up here wants to control it as well. Okay, yeah, okay, I see. Okay. How do we handle that? We handle that by calling the same thing we did. We handle it by pushing it into not backstage passes, which will be easy because not backstage passes down here already, no, it doesn't already do that. Oh, okay. Oh, okay, that's interesting. So we need to go up here and actually extract this into something that's in not backstage passes. So this would be backstage. Well, we'll extract it to a method first to follow all of the correct steps. Private, void, initialize, not Sulfuras here. So that's the same code, which is fine. So we can take this one and we can call it directly. Then we can remove the original code and we can copy this code and we can put it into. I sort of want to just take advantage of the fact that I know that it's a not backstage passes. I guess what we can do is we can put it into the constructor of not backstage passes. That seems way better actually. So down here in the constructor of not backstage passes, but that seems also odd. No, we don't want to do that. Yeah, we want to just push the method regularly. Don't question all of the methods, just do the thing that works instead. I should know better. Is Sulfuras in? Yes, that's fine. And the same thing down here, that's also fine. Oh, I should have made it public. I'll make it public the other place as well. Public. Put this one into the paste bin. Okay. I need to keep an eye on whether the thing is still streaming. I'm super scared that it'll drop out again for whatever reason. Backstage passes dot initialize. Did I not put it into the interface? I guess I got distracted at the last moment, huh? Like that. Okay, cool. So we have some Sulfuras pushed into these now, which is cool. Okay. Yeah. What I'm thinking is there should be some, what's it called? There's some sequence that is sort of implicit right now in the structure of the code. Because we have some things here that depend on themselves, on each other. We need, for instance, we know that we always check h3 before we check anything else. So I feel like that means we know something about some of these values that I would sort of like to exploit. So how can we do that? How can we exploit this? In this case, we always need to initialize so for us, which we then do appropriately. Yeah. So in fact, every time, this one is always called right after these, one of these are called. So what we can do is just ask the constructor of these to call it directly. Because there are no other places where we use these constructors. Are there? Yes, there are. Interesting. So that is not quite true. Okay, let's just not worry about that. Let's see down here. In this class, any way that it can be initialized, it's always going to be not so for us, which is interesting because that tells us something. Right? It tells us that this is always going to call the not so for us to decrease quality. And if we look at the not so for us decrease quality down here, it's decreasing the quality. So by knowing this about the code, we can actually just put this directly. They don't have any state currently, which means that we can just remove this variable, whoops, not the method, the variable. Now it's never used, which means there's no need to initialize it, which is good. So now these two are actually the same method in this class. Let's see if we can also do that, or do something about that in the other class. So here we have solved for us, and this one actually prevents us from doing quite as well because it might be initialized in this case, which is also what I expected. But that's fine. So not backstage passes needs to actually check whether solve for us is correct or not. So let's see if there's something about not backstage passes that we can exploit. In this case, when this initialize is called, it calls initialize so for us. In this case up here, it initializes not so for us. Can we force those to be more similar? I really want to do that in some way. Or want to take advantage of the fact that we know something about the structure of the code. That would be so nice. Oh, it's calling that one, but we should have inlined that one. So it's the same thing. It's just calling two different methods because in one we know what it's going to be, and in one we don't know what it's going to be. Maybe there just isn't a way to join those yet. That's probably just the case. Let's just continue and see what else we can do. So we pushed the solve for us into the is backstage passes, but I sort of feel like we can also push the backstage passes into the h3. So, oh, this one is just a method that calls one thing, so we can inline it. In this case, we want to take all of the things that refers to the backstage passes and push them into h3. So let's just start doing that. Increase quality. Here, okay, good. We can take this method and we can copy it, push it into h3. Here, increase quality, it should be public. That's fine. Let's just take it down here too. And let's put it in here as well. Good, increase quality. So we can call that one down here where we had increased quality. We now call isAgedBrie.increase quality. And that means we can remove that one and we can we can inline that one. Cool. We also have backstage passes being referenced here, so we can also do the same thing here, decrease quality, like that. Let's just, for once, just say we realize those were the same thing, so we move them. That's fine, we copy them. The most interesting thing by now should be the push code into class, not so much the extracting of methods. Oh, into agedBrie, not into the backstage passes. Make it public. Make it public. So we have a tradition of asking during the stream if any of the viewers coded today. Did any of you implement something cool today? isAgedBrie.decrease. Oh, we didn't add it to the interface yet. Sorry. Here, decrease quality, void. Nobody did any code today? Just me? isAgedBrie.decrease quality. We remove that one. This one is just a single line, so we inline it. Okay, good. We have backstage passes being wait. Just everyone is lurking apparently. Well, not you, and thanks for that. Lurkers are fine. I get it. I lurk a lot too when I watch streams. That's fine. It can be relaxing. Maybe people are falling asleep. I know I do that to streamers too sometimes. So now everything is pushed into isAgedBrie, and that means if we look at backstage passes, the only references to it, if we look out here, are actually inside of the agedBrie classes. So we can now take this variable and push it into the classes as well. It's a really nice kata. It's really, yeah, it's great. It has a lot of, you can take it very far, I feel like. And we're also taking it currently probably farther than most people would. But just breaking it down into methods is super interesting, and how you can do that, negating the ifs. There are a lot of other things. It's also a great kata for learning about approval testing, if that sort of interests people. Okay, so now we've pushed the variable into there, and we have no errors. Everything still works. That's good. Okay, so let's just see. Yeah, okay, I see how this is gonna play out. Good. If we go up into the agedBrie here, we actually know what the backstage passes is gonna be, because it can only be initialized in a single way, and that's to this value. Actually, let's do this a different way. Let's try doing it another way. Down here in the constructor, we have isAgedBrie, and it calls this one. It calls it always immediately after the constructor. And that means we can put this call here into the constructor. We can join them, right? That's what I'm saying. So if we pass the same parameter to both of these, then we can just make them call this one on their specific thises. So we can go up here and say isAgedBrie here. It's just called agedBrie. And that should just call this method, and it should take the string name. And then down here, we have the same property, right? Not agedBrie string name. like that. Good. Having done that is interesting for a few reasons. First of all, we can just take this now and inline it, which I feel like is a little bit nicer. Conflicts, inline implements. Oh, it's, okay, yeah. So let's just take this code and put it up into here manually. Or, there are so many ways to do this. Let's just look down here. Why is it highlighting this? Inner class may be static. That's so uninteresting right now. If we go all the way up here, we see that this one is never called anywhere. So we can remove it from the interface, which means it doesn't want to have it here. Yeah, fine, yeah, Java will remove it. Like that, too. Okay, and now we can take this one and we can inline it, because now it's not in the interface anymore, which is good. So it goes up here. Name is unused in this case. That might be interesting. We might actually want to remove it then, just to keep it simple. It makes sense that it's not used there, because it expresses the fact that H3 doesn't need to check anything. It just knows immediately what everything's going to be. Yeah, good. Let's see, in this case down here, we have the same method and we can refactor it away. So that one goes away like that. In this case, we call initialize sulfuras right after these. And in this case, we call another method. That's sort of that was the same case we just had, which is a little bit annoying. In this case up here, we know that backstage passes is always the not backstage passes option. So we can push that down there, which means apart from this single case, we are not using it. So we can also inline it there. Removing that one and removing that one. Now we're calling into these directly, which should be fine. Can we do anything with that? That means this method is never called through the interface. That's very helpful actually, because that means we can, Can I make this smaller when it wants to intrude? That means this one is no longer in the interface and this one is no longer there, but it is still in this class. We can't remove this one. That would be a mistake. Okay, having done that is good for multiple reasons. Coolest of which is that now, in any case where we have these constructors, no. That's so close. That is so close. Can we do anything to help that? H3, new not so for us. Oh, we had that one. What did it do? Oh, it initialized that one. Is it actually used? It is actually used. That's why it's super annoying. In the case that it's not backstage passes. Yeah, sure. Up here, it only uses not so for us dot decrease value quality. And what does that one do? That actually decreases the quality. I kind of just want to roll that back a little bit. Would that make any sense to inline that? We can't remove it, but it might help us. We know what this code is. That's what I'm trying to. I'm discussing in my head. We don't remove the method. We keep it. Inline this only. So it's still calling not so for us because it doesn't know that it's just a value we created. We know that the constructor doesn't do anything, so we don't need it in this case. Okay. We have more places where we know what's happening. Specifically, up here in the aged brie thing, where we know it's not backstage passes that decrease that quality, which would be not backstage passes. This one, no, this one. Oh, but that uses the sulfura, so we can't inline that just yet. I really want to get rid of some of these things. Initialized not sulfurous. Let's just, oops. No. Redo. I want to just fold this out. That was also not what I wanted to do. Can I just say inline this one? Oh, it has the sulfurous. Are they not private? Why could I assign that one? They are private. Oh, but we're in the same class. Yeah. Gotcha. I really would like to get to a place where we can do the same thing to some of these that we did with the other things. But we might have hit the limit. I just feel like that's not the case. If these are backstage passes, then we know what this is going to be. It's going to be the not case. If they're not backstage passes, then we need to initialize it. And what's messing that up is the fact that we had this place where we initialized the not sulfurous. Because we know what it is. So what we can do we actually need the not, we don't need the, we're not doing anything with it, are we? Not so for us. I mean, we're throwing this variable away. So in fact, we don't need to do this at all. We're not storing the value. That helps a lot. That actually solves the issue. That's great. So now, everywhere we have any of these, no, still not. What does increase quality do when not solved for us? It does something, right? Not backstage passes. Increased quality doesn't do anything. Is that true? Is that accurate? That was not the one I wanted to. This one. What does this do? Yeah, it does nothing. And so calling the constructor also does nothing, because it does nothing. The decreased quality, though, I feel like it does something in the not backstage case. It calls this one. Yeah. That one is unused, which is nice. Cleaning up. Do we have anything now that's unused? No, not yet. So this wants to know something about sulfurous in that one. But sulfurous is not going to be initialized. Yeah, it's going to be initialized to the not case, which means it's going to decrease the value. And that's what's going to happen in that case. That's very far-fetched. I'm pretty sure it's true. It is true. In the case that we have not backstage passes, we would have called the initialized not sulfurous, which means it would have called that one. We skipped a step somewhere, which was bad, but I'm pretty sure we're back on track now. So, yeah, and we can check that, like do a sanity check by just being like, an aged brie, what would happen if that tries to increase the quality? It shouldn't be able to increase the quality at all. Is that true of the original code? Let's just check it out manually. Now I'm quite curious. HBRE, if it's not HBRE, but it is HBRE, that means if the quality is less than 50, which it might be. Then we go in here, we say quality +1. Did we miss a step somewhere? We might have missed a step. Or did we? No, we didn't. Because the quality is increased there, that's this one. And then the rest of it doesn't increase with the aged breed. Yeah, so it's still good. This is fair, and it's awesome because then now, in any case where we have a constructor like this, we call this one, which means we can push this one into the constructors, which was what we were going for all along. Let me just take the name here and then put it into the constructors of these classes. So let's go down here and make a constructor, which would be backstage passes. And that constructor just needs to call that thing. We need the semicolon and we need the name. We have the same constructor down here with a not in front. Everything should be all dandy, good. Initialize sulphurous is now not called outside, which is important because then we can remove it. And then we need to remove the override and the other override as well. And now this is called from only one place, so we inline it. And the same thing up here, we inline that one, which means the constructor is just doing nothing, which means the name is unused. We're back to doing the same thing. I love it when it feels like we're cycling back to things we had earlier because that makes it seem like we're on the right track. Doing small things is better. Okay, this we can't do anything about because it's all good, all good. This is interesting. Do we call this thing from any other place? I don't think that we do now. So we might actually just push that method into that one. Decrease its global scope. It's not going to be a huge improvement. So I guess we'll just not. Decrease quality, yes, okay, that's all good. Update quality, including backstage passes. I guess we should actually start pushing some of these methods down into this stuff. Is not HB. All of this stuff has to do with backstage passes. So now the question becomes, can we do something about that? Can we say that instead of doing, we want to join them, right? That was the idea from basically hours ago. Actually, maybe, how are we gonna do that? Is there a reasonable way to join them that makes sense in a logical sort of way? Well, they have the same methods. They had to have the same methods because otherwise this wouldn't be possible with just calling. They're even called the same. So what we could do is just make a new interface. We're going way past both the content that's in the book and, well, let's call it something other than that. And what I've done before, I'm pretty sure. This would have the same methods as this one. And then we can say this implements these two, not Bree doesn't implement them, but then this one does, and this one does. So that should be, so that we can actually remove this one now. Which means down here, it should error because now we want that to be the new item temp. And it's complaining because it's being like, well, what about this thing? That's a good question, but we can take that straight out of the constructor right here and just copy this code and put it in here. Can we make it? Oh yeah, and now this one is unused. Which is super interesting because now this one becomes unused. That's nice. Could we break this one so that it looks nicer? What about this? I don't know. It seems nicer. Okay, so we have that. Backstage passes thing became unused. That was super cool. I kind of want to do the same thing for sulfurous now. Just having this one be pushed into the other one. And we can just push it directly because there's nothing in it. So this would just be pushed into the sulfurous and the not sulfurous and the interface here. This disconnecting is just killing me. I'm really sorry for it, guys. It's the new internet thing. I need to get it fixed. Maybe we should actually just call it a night now. Thank you very much for joining me tonight. I'm really sorry for the interruptions. They've been super annoying for me as well. They do not happen on my regular stream, which would be at the Dr. Lambda. So yeah, and you can also find me on Twitter, and you can find me on GitHub, and you can find my Medium. All of them are at the Dr. Lambda. So you can reach out and chat with me about anything, and you can come hang out in the stream if you want. I stream every Thursday, and I think I'm gonna start streaming every Tuesday as well now. So and it's always code. It's just fun stuff. Sometimes it's games, sometimes it's refactoring. Whatever people want to see, we're doing that. I want to thank you very much for joining. I had fun. I hope you did as well. I hope you learned something. I know I did, and I hope I'll see you some other day on the stream. Have a great day.